Greetings all. My name is Stacie Doucette, and today we are going to talk about the different methods used in integration. There are close to a dozen different methods that can be used to integrate a function, but today we are going to discuss U substitution, trig substitution, integration by parts, trig integrals, and partial fractions. U substitution is one of the simplest integration techniques that can be used to make integration simpler. In its most basic form, U substitution is used when an integral contains some function and its derivative. The integration is achieved by rewriting the integral in a form that makes it easier to read. This means you rewrite the function as u and its derivative du, and you integrate accordingly. After you find the much simpler integral of u and du, you sub back the original functions and add a plus c. In the end answer, the du function should be eliminated, and the plus c refers to the constant of integration. This means that the derivative of a constant is 0, so when we reverse the operation to find the integral, there could have been a constant of any value. We acknowledge this idea just by writing plus c at the end. This is only done for indefinite integrals. This means integrals without bounds. Next is trig substitution. Trig substitution refers to substituting inverse trig functions into the original integral problem. To do this correctly, it is important to know which inverse function to use. They are to be used as follows. Whenever you see 1 over the square root of 1 minus x squared, think sine inverse of x. Whenever you see 1 over 1 plus x squared, think tan inverse of x. And whenever you see 1 over the absolute value of x times the square root of x squared minus 1, think secant inverse of x. After you have manipulated your functions into the appropriate trig inverse functions, you must use a triangle to determine what substitution should be made. You do this by labeling theta in your triangle and using SOHCAHTOA to place xa and the function. The next method that we are going to discuss is integration by parts. IBP, as we will refer to it in the future. IBP is done to reverse derivatives done by the chain rule. In these problems, you should have already tried to do U substitution and trig sub. If those did not work, look at your problem to see if it looks like two functions being multiplied by each other. If so, consider that a green light to use IBP. To successfully complete IBP, you must identify what you will label as u and what you will label as dv. U is a function that you can easily derive, and dv is the function that you can easily integrate. If this still confuses you, try using the acronym LIATE. LIATE stands for L logarithmic functions, I inverse trig functions, A algebraic functions, T trig functions, and E exponential functions. So how do we use it? Well, whatever function from that list comes first should be your u. After you have your u, derive it to find du. Take the leftover function and label it dv. Then find the integral of that function and label it v. Once you have these four parts, plug them into the formula u times v minus the integral of v du. v du should be much easier to integrate, but do not be discouraged if it is not. Sometimes it is necessary to do IBP several times to get an answer. Some functions will repeat indefinitely, in which case there is a trick that you can use. Once you have completely returned to your original integral, you can use algebra to solve for what the integral equals. This means subtracting or adding it to the other side of the equal sign and dividing by any constants. Our fourth method in this lesson is the use of trig integrals. To use trig integrals in integration, there are many identities that you must know. The most prevalent are called Pythagorean trig identities. These identities are based off one simple equation. Sine squared of x plus cosine squared of x equals 1. If you know this one, then it is just as simple to find the other two. Simply divide that whole equation by sine, which will result in 1 plus cotangent squared of x equals cosecant squared of x. If you divide the original function by cosine, you should get tan squared of x plus 1 is equal to secant squared of x. Other important identities are the double angle identities, which state that sine squared of x is equal to 1 minus cosine of 2x over 2. Cosine squared of x is equal to 1 plus cosine of 2x over 2. And sine of 2x is equal to 2 times cosine of x sine of x. You will use the appropriate identities to rewrite your integral problems. More specifically, when you have problems that feature trig functions raised to a power of 2 or greater, look carefully to see if it can be broken down. Take, for example, the integral of sine cubed of x. Break sine cubed of x down into sine squared of x times sine of x. Same thing, right? Next, you rewrite that sine squared of x as 1 minus cosine squared of x. Now you have an integral that features a function and its derivative. Sound familiar? That's right, u substitution. Now you can use your sine and cosine function in u substitution. Last but not least is the method of partial fractions. This method is based on the simple concept of adding fractions by getting a common denominator. Make a note that this method can only be done if the degree of the numerator is less than that of the denominator. To start these problems, take a look at your denominator and see the best way to factor it. Once you have broken down your denominator into its parts, each factored part of the denominator will have its own relating fraction on the other side of the equal sign. In this case, the factor is the denominator and the numerator is labeled A, B, or C as needed. The numerator reflects the denominator but is 1 degree less. For example, for a denominator of x plus 1, the numerator being 1 degree less would be just A. For a denominator of x squared plus 1, the numerator being 1 degree less would be ax plus b. Once you have set up all the fractions, we use algebra to find the coefficient for each term. You first have to set up common denominators, which when simplified will appear as the original integral equal to a times a function plus b times a function. You then substitute a number for x that will make your a or b term 0. Doing this on both sides of the equation makes it easier to solve for your coefficients. Once you have found all of your coefficients, plug the numbers back into your fractions. You should then be able to use one of the previously discussed methods to integrate the fractions. That is all for now. Thank you for your time.